Alaikum warahmatullahi wabarakatuh. Good morning, everyone. Today, we'll talk about remote sensing and GIS for smart cities, insights, innovations, and impact. Okay, so for our agenda today, we'll go through, first of all, smart cities and smartness. I hope my sound is heard well.
It's clear, Mr. Hussein.
Okay, thank you. And then we'll talk about GIS, BIM and smart urban planning, as BIM became a boon for urban planning smartness, and its relations to GIS, or geospatial science in general. Then we'll talk about smart cities and digital twins. That will be followed by use cases actually, starting with the smart city scan. It's a current project actually currently running by Dubai municipality, which reflects the idea of implementing smart technologies to innovate operations for a smart city. Then we'll talk about smart city elements and geospatial solutions. How do we relate the elements of smart cities and the geospatial solutions? This will be followed by data acquisition for sustaining smart cities via digital twins. And then hopefully, if we have some time, we will see some use cases like mobility using remote sensing and GIS, geographic scale remote sensing for smart cities. And finally, we hope we can reach to see the use case about urban change assessment. Smart cities, it's actually a topic of a very important topic because it shows the quality of life. It aims to the happiness of people. And it's something that we deal with daily. And also governments deal daily with the smart city issues to improve services, to make people happy, etc. So let's discuss a little bit about smart cities, the rise of smart cities and urban development. So that's the core concept of smart cities. Tech-driven urban evolution, technology streamlined operations, improved resource management, and enhanced quality of life for residents. So important factor here is the use of technology. So we need we need smart people with smart infrastructure, and smart planning, and smart governance. Sustainability. So we need smart people, and we need smart technology, of course. So the smart cities leverage network of sensors set everywhere, important places that will drive the information, spatial or non-spatial information, directly to be analyzed. So we need data analytics. We need internet connections, Internet of Things, IoT. Even now we are looking at locally processing Internet of Things and using artificial intelligence to analyze big data, of course, big data insights and artificial intelligence to analyze this data and provide information that can help the city Sometimes, for example, for security and safety, we need to act immediately. So to gather information and optimize everything from traffic flows and energy use to public safety and waste collections. Here in these small tables, we will look at them a little bit later. Here, smart city components. This is just an example, actually, because in the literature, you will find a lot of different things, different elements of smart cities. But generally speaking, anything that drives the city to be smart and that will be reflected on the happiness of people. So you need smart infrastructure, smart governance, mobility, smart mobility. You need digital citizens. So digital citizens, it means that they know how to use the technology. They are experienced with the technology. And they also have big knowledge about smart cities and how to be smart. It means smart people. We need open data and information sharing data. We need smart health, of course, smart farming, etc. Smart buildings. Now, if we talk about smart buildings, that is something internal. It's something internal. It means that the building uses electronics, it uses safety, it will like for energy saving, etc. But this is internal. Now, for spatial or the relation to the spatial components, we look at the external smart elements more than the internal ones. Smart digital energy, we need smart digital energy and smart transportation. Understanding smart cities. So act that may lead to happiness, city-nation-based smartness, which means that what makes people happy in London may not make people happy in Dubai or Abu Dhabi. So smart elements should be tailored to also city and the culture of people. So current citizens and thinking about current citizens and future generations, which means sustainability, which means not consuming everything, but leaving something for the future and building something for the future. So we can see in the picture about smart cities, government, life quality, social inclusion. Social inclusion is when you include also the people in this decision. And that is something to do also for governance. Smart buildings, natural resources, using more clean energy resources, taking care of the environment, and smart transportations, like, for example, trying to work from home, using public transportation, reducing traffic, etc. Environment, urban services, a clean city, public security, you can go walk, you are not afraid, and healthcare, of course, and education. So it means that the city is also providing opportunities for improvement, opportunities for economy, etc. These are some quoted definitions of smart cities, but they are a lot, of course. But these were researched by myself and with references. Of course, I didn't put the references here, but if someone needs to know about the references, I can provide that. So we just have a look at some of them, like cities and societies that leverage digital solutions constructed according to a common technical foundation and that possess organizational structures that enable citizen involvement in an innovative ecosystem with the aim of increasing livability, sustainability, and prosperity. And then some cities or communities are rapidly expanding to create new economic opportunities. But this is important, very important. It's not that the city is only working, but creating opportunity, conserve the environment, and enhance citizen services. Then a smart city uses information and communication technology. That's also, so the use of the technology in smartness to improve operational efficiency, share information with the public, and provide a better quality of government services and citizen welfare. The main goals of smart communities also had tasks, is to use digital solutions to address the challenges of a city, county, or a region. Why? To conserve resources. So it helps you, people know how to use the digital solutions. It will help and improve the smartness of a city, improve the well-being of citizens, and then periodic potential hazards, take preventive actions such as flood detection, etc. And use data and digital platforms to improve citizen involvement for healthcare or social services, make environmentally friendly choices along with clean energy. Let's look at IBM's definition. One that makes optimal use of all interconnected information available today to better understand and control its operations and optimize the use of limited resources. We will not go through everything. I just selected some of definitions for you, just to get the feeling about how important this topic is actually. Now, different cities have different examples, different actions, different governance. And this is the example of Dubai. Actually, this was at the research time. Maybe it's improved now or changed a little bit, but this was the Dubai example. So to create happiness, the mission is to create happiness by embracing technology in innovation, making Dubai the most efficient, seamless, safe, and impactful experience for residents and visitors. So see how this part is important. And Digital Dubai is communicating with different government entities to make sure that each government takes care of the related factors of the smart city. So the city should be efficient, should be seamless, safe, impactful, and then economical governance, the people, let's see, culture of continual learning, innovation, and participating in an inclusive society. Living. So these are the elements of a smart city, like living, exceptional quality of life, accessible education, healthcare. So city that it's providing opportunities, and then environment, mobility, and environment. We'll come to the second topic here, where we'll talk about BIM, or BIM is actually very important because it's not only information about buildings and internal information about buildings. BIM can also be for road structures, for bridge structures, for all structures of the city. It means that you will have complete gathered online and interactive information about infrastructure, and then if you connect that with geospatial technology, you can do a lot. So the digital backbone of smart cities, BIM becomes as a game changer for smart cities. BIM creates digital representation of buildings, or infrastructures. It goes beyond just 3D. It's not just 3D drawing. It incorporates a rich database of information about the building, including materials, energy, efficiency, ratings, and maintenance. You can see that build, create, integrate, and design. Now, if we look at the graph at the right side, we can see that BIM takes a lot of factors like collaboration and then integration, viewing the project, centralization, etc. So we are gathering information about not buildings, roads, and different infrastructure. And here is what Dubai municipality provided for that. So as a smart city, this is a use case where all constructors, all should can have all the necessary information to make a smart building. That it has been, it is built according to high standards. So Dubai municipalities provide the information and the full support from stage one to the end of the building. And especially for the large structures, especially for the large buildings and large structures and so on. You can see that there are different stages for this BIM work, and information will be provided for all the stages, like the accessibility, the architecture, the security, etc. So how to do? What are the regulations for large buildings? Is it necessary to put a cam at certain places, etc. And all this information is provided online, and support is given by the municipality. So now we are starting to come to how GIS and geospatial technology will help the city. We're starting to think about digital twins. Digital twins is the replication of the city in a digital way. And if all the data and information is available, then we can maintain the city, we can analyze the city, we can help the safety of the city using the digital twins. Now, this is where there is an interaction between the physical world and the virtual world. We can see here that digital twin is just actually before it was called the base map of a city, right? So, but now because it's digital, it's a 3D, it's interactive, so it is smart, and that's why it became the digital twin. So in the digital twin, as we mentioned, it's just a copy of the city in a different scale, but you can zoom it and get more information. So the more information we have in the digital twin, it is the more powerful. So we use the terrain, the infrastructures, the buildings, the mobility information. Here, we will add to the digital twin also smart city information. This is, they are operations you use on the digital twin. You can, once you have the digital twin and then you have the information, you can do a lot of different analysis that will help the city, and help the emergency response, for example, and resilience, help the engagement and participation, etc. So here we can see that interactive 3D asset analysis and simulation. You can analyze the information that is coming directly from the field. Any update is reflected on the digital twin. And you can do traffic management in case of conjunctions, etc., plan other roads, etc. And you can do asset management, such as knowing where the light poles are, etc. and traffic indexes simulation. So on digital twin, you can do any kind of spatial analysis and also automate that. You can automate that. So you will get the information reflected to the decision makers directly. Like you can do also real estate management, knowing where are available uh, lots, and then this will help also the city arrange accommodation. Here we talk about smart cities and in integration of BIM and geodigital city twin models. So data interoperability, it means that we will have because BIM and GIS are in different system, different standards. So we will use standards to exchange data and understand. As a smart city, you can see in the middle, it is a connection between BIM or urban planning in general, city planning, and GIS. There is a complexity part because of, as we mentioned, the different standards. Privacy and security concerns. Smart city models collect a lot of data, rising privacy concerns. So things we need to deal with. Standardization. Now here we came to the use case of Dubai municipality, which is current now. And this use case actually reflects the flow of the information, the geo information, into the digital twin. So we designed a collection of data using sensors mounted on cars, on municipality cars that are revolving in the streets, and also using satellite images such as Khalifa Sat and artificial intelligence to detect changes in constructions. Also, we will use cams. We'll show that cams in construction sites, and we use drones also to detect any violations in the buildings, on the roads, etc. So this data will be collected using the Internet of Things. So some of it will be processed immediately and sent to digital twins, and some data will be post-processed. So enhancing smart city compliance through automation. The challenge in smart cities, sustainability is compromised when planning and constructions are not aligned. So like violations, unpermitted buildings, extensions, or neglected maintenance, etc. So the project aims to automate the inspection and monitoring, reduce reliance on manual visits, and improve accuracy, speed, and resource efficiency. So this is an example of a smart city. Proposed solution detection using artificial intelligence, as I mentioned, with deep learning, and yeah, sensors and cameras. So here we can see that we're also using cameras and in construction sites. This data is collected like big data, and then it's analyzed using artificial intelligence, and all violations and aspects to be reported goes directly to the systems, databases, and digital twins, and then it's analyzed and will be reflected to decision makers. Now here we come to where the interaction between smart city elements and geospatial solutions. So as you can see on the left, these are some of the things we mentioned already that help the city becoming smart. Things like for example, electric vehicles, and then like wind turbines and solar batteries, etc. But on the right side, this is a very important table here, where it was done using the study I mentioned, because there are a lot of operations in the city. A lot of operations you can see down. It's written a lot of, like, for example, study traffic flow, uh, like, for example, flood studies, etc. So there are a lot of operations done for the city. And then you will have the elements of the smart city: resilience, livability, sustainability, safety, and mobility, etc. So it's a lot. So how to do it? We plan to generalize, take the actions, the proper actions, and segregate it. Like, for example, we segregate traffic and so on to mobility. And then once it's segregated, it's put in place, it's understood, then we start thinking about what is the geospatial solution. In this other table here, we look into smart city feature, and then smart feature components, operations, and then we will see the smart geo solution. So once we understand the operation and the category, for example, mobility, and then reduce traffic, better transport, etc., then we start thinking about the geospatial solution that can help and support the smartness of the city in this element. Once we've done that, we will design the geoinformation data. So we will check what type of data we need, like road data, networks, pedestrian networks, etc. So then after that, we see how to effectively collect this data acquisition methods. Do we need land surveying? Do we need mobile LiDAR for that? And how frequently do we need that? And how accurately we need that? Do we use image interpretations? Can we do that using satellite images, etc.? And we'll check if crowd source information is helpful in this case. And can we rely on it? Or does it need quality assurance and quality control before using it? So this table is very important. This is where smart city elements interact with geospatial technology, actually, data and solutions and analysis. On the right side, we just have a look at the Dubai municipality use case, where digital twin is used for urban performance and insights. Now here, data acquisition for sustaining smart cities and digital twins. Here we can see actually the digital twin, and then traffic management, traffic monitoring, open data, smart parking, etc. All this. How do we connect this with this digital twin? Here we need to think about data acquisition quality. It means a complete set of data collected, designed to update digital twin. So as we mentioned previously, you made the table, you interconnected the smart city elements and operations with the GIS or geospatial technology, and then the method of data acquisition. And then here you need to think about the rules that should be, some of the rules that should be taken and considered. Each data collected set is designated to one or more technological solution, a continuous intelligent loop of data acquisition. So it's continuously collecting data either by fixing a cam or, as we mentioned, by a car roaming around the city, etc. Or drones are going into collecting data from certain places using satellite images. So depending on the data type, the data scale required to analyze that uh, special issue, for example. Self-controlling and adjusting procedure. It should be self-controlling. It collects data when needed. It processes data when needed. It can increase the data collection in certain timings, etc. Intelligently communicate data acquisition requests to system. There are data acquisition requests which are coming maybe automatically, and then intelligently it can send to the systems. And automatic dashboarding. So all this information and results can be dashboard, can be sent to decision makings, alerts to city planners and city managers, etc. So these are some of the regulation. This is actually, we can call this a smart data collection for smart cities, for smart digital twins. Here we decide what type of, as we mentioned, what type of data acquisition method. Like, for example, a city needs data collected by aerial images. Why? To get better resolution, to get precise 3D information for the city and get it updated. That one you cannot get from satellite images. And if you cannot do it using land surveying, because land surveying will be good only for cadastral, and it's very expensive. So a complete set of data collection designed to update digital twins. Each data collection set is designed one or more technological solution, maybe more. Like, for example, we have a LiDAR car in Dubai municipality. It's roaming around collecting the LiDAR data. So we design it and complete this data using aerial photography. A continuous intelligent loop of data acquisition. Automatic dashboarding, we mentioned this. Self-controlling and adjusting procedure intelligently communicated. Okay, we mentioned it. Aerial and terrestrial integrity and point clouds from laser scanning. These are examples. Remote sensing imagery, interferometric synthetic aperture in SAR for weather data, sensor generation. So we look into what is needed for what and design the correct data collection method. Design the frequency of data collection, design the proper quality, not over quality, over accuracy, which will cause more, will need more budget, and not less quality. So that it needs to be collected in a smart way that you can use it for specific analysis, and that analysis will add a value to city smartness. This is a use case, an example, which was done using remote sensing and geospatial technology to prove the mobility part of smart cities. And it's nothing but using satellite images, using artificial intelligence, and analyzing the infrastructure after building all the project and collecting the data, etc. Then using GIS functions and tools to calculate the different the distances for features or for important structures to the road. This is actually in Hatta. And you can see the arrows, and the arrows, they have a magnitude. And then you can do this analysis for a lot of cities, and you can see that in general, how mobility works, how the quality of mobility in the city. So if there is, for example, in one place an issue, health issue, and so is mobility good for like security and safety movement or no, etc. Maps from Google Maps, generated maps based on real and fake satellite imagery. So it means we need to take care of using artificial intelligence. If we get results, if we get, so here they wanted to show that there are dwelling and buildings in the area, which is not true.